happiness.
All right, well, thanks everybody for coming. Plan 9, I've been working on it for a couple years now, so I just did my last co-op with it. So I'm, want to spread the hot gospel, if you will. Together a little presentation. By the way, that's the Plan 9 mascot of sorts. Where Linux has Tux, we have Glenda. Glenda the bunny. And so in this presentation, I'm going to go over the motivations on why they decided to make Plan 9, talk about some of the features that it features over Unix or Windows or anything else, where they're using it today. I'll give a little demonstration on the system itself, and then I have some stuff about if you want to try out Plan 9 for yourself. So, about the history. Unix started developing it in 1968. And so this was at Bell Labs. By the late 80s, they decided it was getting kind of long in the tooth. In the time since then, they'd come up with graphics, networking, microcomputers were around, they were a lot cheaper. And whereas Unix was designed to be sitting on a mini computer locked up in a server room somewhere, and everybody uses text terminals. So Rob Pike said, not only is Unix dead, it's starting to smell really bad. And he was on the Plan 9 team, and along with pretty much everybody who had done Unix at Bell Labs to start with, so like Dennis Ritchie, Kernighan, all them. And so they decided they're going to try again. And as they say on the website, some parts of Unix were too broken to fix, but some of the better parts could be brought along with it. For example, they saw no reason to ditch the like pipes and command line interface where it's useful. And so while others were making Unix clones, like about this time we were getting Minix and Linux and the various BSDs, Bell Labs decided they're going to make a completely fresh OS. And thus Plan 9 was born. They decided from the very beginning they want to have it incorporating graphics, pervasive networking, meaning that you don't dial up or anything, you have Ethernet, and you're always connected to it, and it's fast, so you can send files and store files remotely. And we're going to distribute how computation and authentication are done, and I'll talk about that later. And they're going to add some new features too, stuff that they thought would be nice to have in Unix, but Unix didn't really allow you to graft it on very easily. Unfortunately, Plan 9 was developed in the early 90s and continues to be developed to this day, but it wasn't open sourced until 2000, which means that there wasn't a lot of adoption up until 2000 when it became free, and then people started using it, but Linux had already established a foothold as a free Unix-like OS. So the important concepts to know about Plan 9, and if at any point when I'm going through this and the features, you have a question about something, like let me know so we can address it while I'm on the topic. Some important features, division of services. The kernel is small and portable. Everything is a file, even more so than in Unix. Networking is pervasive. We have storage that lasts forever. Use the C language for pretty much everything. Have good non-GNU utilities and strong graphics capabilities. So division of services. The idea of Plan 9 is that you don't have to run everything on one machine. Ideally, you'd have a network set up, and you'd have these 3 core machines: the CPU server, the file server, and the authentication server. Now, the CPU server does heavy computation, so if you have a really large, a lot of data to crunch through, you'd run it on the CPU server. Now, the file server does one thing and one thing only. It stores files and serves those over the network to the CPU server and the auth server, and then the terminals which the users use. The authentication server is there because Plan 9 has a pretty centralized form of authentication, and it's more secure to do all the authentication on one separate server than to split it out or to do it on the CPU server or on the file server. And then the terminals are what you sit at. This is booted as a terminal right now. It's pulling its file system from a server right upstairs, which is currently set up to act as a CPU server, file server, and authentication server all in one, because I couldn't get 3 computers. But the idea behind this is that you can now get a bunch of really cheap microcomputers, PCs, rather than in the old days when you had to buy, you buy a PDP-11, which costs you $50,000, and then you would stick, terminals, text terminals, which only cost $1,000 around it. Now everybody can have a PC on their desk, so we can distribute things a little more. Now the kernel. Kernel is really quite tiny compared to Linux. We're looking at about 46,000 lines of portable C, which are common to every architecture it runs on. And then 83,000 lines of PC-specific C and assembly. There's just a little bit of assembly, the minimum possible, because we figure computers are pretty fast, and this is a small kernel, so we can write it in C if we want. We don't have to go hand-hacking assembly. Besides that, as you all probably learned in your various classes, machine-generated assembly is usually faster than something you wrote yourself. And as a result, it's easy to hack on the kernel because you can keep the whole thing in your head at once. There's not a lot of system calls, unlike Linux, which has like 256 or something. Plan 9's got about 40. And that's due in part to the way it was designed from the beginning. And when you build the kernel, you customize it in certain ways to be a CPU server or a file server or an authentication server, which means that you trim out a lot of stuff that you don't need for whatever specific task you're using. And it results in a kernel that's only a couple megabytes. Coming back to everything is a file, like this, you all know this from Unix, but Unix has special files that aren't really like all the other files, like device files. We took that further in Plan 9. Everything is a file, even device files act more like regular files. In addition, you get private namespaces. Now what a private namespace is, every process has its own namespace. And what that means is that, unlike in Unix where you say like, mount the CD-ROM drive and mount it to /CD-ROM. You have to be root to do that because then that takes effect for everyone. On Plan 9 you do that and it only takes effect for your current process, which means that anybody can mount anything, anywhere. And with that in mind, we put in binding. And what that means is if you want to bring in one part of a file tree to another, you can do that. So if you have, where's some board I can use? Okay. So if you're working in user/John, and you want to have the kernel source tree, which is in sys source 9, if you want that to be local to you, I don't know, so it's more convenient to use, you can say bind sys source 9 to user John, and now you can see every file underneath this directory in your home directory. And that's a pretty powerful concept, and it makes a lot of things a lot easier. Stuff that on Unix would be a big old C program, we just do in a shell script of a couple hundred lines. Let's see. Devices, they usually have a control file and the data file. You configure it by just echoing stuff straight into the control file. And then you get data or you write to the screen through writing stuff into the data file. It's a little are you guys understand what I mean here with namespaces, binding, all that? Yes?
Is there more to binding than what you described there? Because that looks like a simple link that you can do on any Unix system.
But see, what happens is that you run this in your shell, and that's only visible to your shell. And no other program sees that. And so you can do this as any user. And it's temporary. When you kill that process, that goes away. And so the idea is that you build up your own namespace the way you want to see it. And then nobody else has to deal with it, and you don't have to deal with it. And that reminds me of something that we do. Instead of having the path like on the Unix shell, there's just /bin, and then any programs that you want to be in /bin, you just bind the location that they're in onto /bin, and then you just look in there. Your shell will look in there. Yes.
So are you kind of saying that not only it's even more than a symlink, everything's just overlaid? Yeah,
it's okay. Overlaid. And if you do a bunch of binds, you can actually see multiple copies of. You can have files with the same name in one directory. It's complex, and some people have a lot of trouble getting used to it. I know it took me a long time to figure out what the heck binding did. but it becomes pretty powerful. Similarly, network connections, they're just files and directories. Oh, I'm sorry, I missed you.
I thought when you bound a directory in Plan 9, anything that was in the destination took precedent. If there was a name collision, anything in the destination took precedence.
Well, what you do is you say bind it before or after.
Right.
So stuff that's already there will either show up before or after the new things you're binding.
Well, yeah, you can choose, but you won't get both. You can't have two files. at the same
Right. They'll only show up when you ls. But yeah. Let's see. Network connections, they show up as files and directories under /net. So you don't really deal with sockets. You just say open a new file. You can create a network connection just using echo and cat and such. We're also where /proc came from under Linux. You all probably know about that. Let's see. Pervasive networking, designed with networks in mind. And then here's the thing. This 9P2000 protocol, which everything uses for all file system access, you can bring that across the network very easily. So not only can you bind things from your own computer, you can transparently access files on a different computer in the same way. So I'll show that in my demonstration to get a better idea. But basically, for your programs, it doesn't matter at all whether the file you're looking at is local or remote. Internal storage. This is, as it said on the poster, that there's a file system that acts like a version control system. This is what I'm talking about here. So there's Fossil, which acts like a cache. The names are rather arbitrary. Fossil acts like a cache for the new data. So you'll have a couple of gigabytes of a Fossil file store. When you create a new file, the file gets put onto Fossil. And then the next morning at, say, 3 a.m., Fossil goes through, finds all the new data, and then writes it to Venti, which will be a couple hundred gigabytes, as much space as you have. It does it blockwise, so that if you make just one little change to the end of a file, end of a really large file, it doesn't re-back up the entire file. It just backs up that last bit you changed, and then links to the old data. Like I say here, it's kind of like Time Machine. Anybody who uses that on OS 10? Yeah, so it does that. Similar in concept, but technically superior, since apparently Time Machine copies the entire file all over again. And all your old files from any day are accessible on your file system. And I'll give a demonstration of that as well. Here's an example. If you, for some reason, you deleted your important homework assignment. Oh crap. So then you say 9fs dump. Which means, okay, show me the dump file system, Venti. Bind that binds that to n/dump. And so then under that, there's a hierarchy of, there's the year, month, day, and then there's just your regular file tree. So I could say, copy the old file, important homework.txt, the one that was backed up yesterday morning, here again, to where I just deleted it from. So now you have the file back from the last time it was backed up, which would be yesterday morning automatically. And it really makes you a lot less scared to go messing around with source and such. Like I'll just jump right into the kernel tree and start hacking around on there. And if I screw something up, I just say, okay, bring back the entire tree from yesterday. Yes?
Now, can you have it go in increments more or smaller than a day? For example, if I'm going to be messing around, I'm probably going to be messing around more than once in a day. So is it possible to force a backup?
Okay, so there's multiple things. Fossil also does snapshots. So like every 15 minutes, Fossil will grab a snapshot of the file system. And you can do the same process, like you'd use n/snap, you'd 9fs snap, then look at n/snap/whatever, and you'd be able to find the backup from 15 minutes ago. And you can also configure it to make make it dump to Venti every day, every half day, every 3 days, or whatever you want. But most people have Fossil take a snapshot every 15 minutes and then back up to Venti every day. And then it clears the Fossil snapshots every couple days. Okay, pretty much the entire operating system is written in C. Oh, yes. Sorry.
You said it updates at like 3 in the morning. Can you change that? Is that?
You can. I was having problems because I think ours was set for like 7 in the morning at my last job, and the problem was I'd come into work and it would still be backing up. I hadn't configured the server right; it didn't do DMA, so it was really slow to write to the hard drive. And so I eventually pushed it back to 2 a.m. And it's not hard at all to change that. We're all written in C, and it's got its own dialect. When Kernigan and Ritchie and everybody who basically wrote C originally were working on Plan 9, they said, you know, we don't think we want to do POSIX compliance because we wrote C 20 years ago and things have changed since then. So they made their own version of C. It's a little bit different, looks like C, some of the function calls are different. We've got our own libraries, which again, you know, standard I/O, things like that. And then we also have a make like, it's called make, but it works a little bit differently from Unix make. It's basically what the C guys thought C should be like now after the post-ANSI standard. We also have a POSIX compatible compiler and shell and things, but that's for compatibility. You shouldn't write code that depends on those. Example, hello world. You notice some differences. I mean, it's POSIX C, you just write include standard io.h. This main would be an int, and you'd say printf, and instead of here, we got rid of the of exiting with a numeric code, and you can now say something like, you can say exits and then give a reason for exiting. You can say exits, I'm done with my process. I just said nil there because that's the equivalent of exit 0. Utilities, we don't really like GNU. The canonical example is to look at cat, which has like 50 options in GNU, but it only has maybe none on Plan 9 because what happened is that features kind of crept from one program to another. You find cat doing stuff that should be done by some other text processing program. And so we tried to go back to the original Unix ideals, which is that everything should read from standard in and write to standard out when possible. And for convenience sake, you can usually have it read from a file. And then you also assume that the output is going to be sent to another program. GNU LS, it does some fanciness to see if it's being piped or if it's being written to a screen. And if it's being piped, it'll output in single column format. If it's being written to the screen, it'll be done in multi-column. We said, that's kind of silly. So LS does it in one file per column, or per row. LC is just a shell script, which is LS piped through MC, which means multiple columns. So we pipe that output to something that puts it in multiple column format. Pretty much all the utilities are written in C. There's some that are in the RC shell because of the way Plan 9 is made, it became easy to put it into the shell. And finally, I think this is graphics. Use DevDraw. It's easy to write a graphical program. I'm going to show you one that I wrote. The snake game, which is what I'm going to show you, took about 200 lines of C, including comments and white space. The windowing system and the editors really focus on using the mouse, and this caused a lot of argument on the mailing list because AVI users will say, or Emacs users will say, well, it's so much faster to use the keyboard. Somebody else will come in and say, no, it's much faster to use the mouse. You guys are stupid. There's tricks in the Plan 9 editors and the windowing system which make it a lot more sensible to use the mouse. And, oh, I forgot about this. All right. Plan 9, we're currently using it on the 386 architecture, which is the primary platform. It's just being ported to AMD 64. It's a little behind the times, but it's kind of a scratch your own itch thing because the community is so small. The people I'm working for decided they wanted to scratch the AMD 64 itch, so we're doing that. It's also running on the IBM Blue Gene /L and /P, which I got a chance to work on those. It's very impressive and runs pretty nicely. And you'll find it used in embedded systems. There's a company called Coraid, which does network address storage. It's in supercomputing. The FastOS project is using it. And a lot of people use it for personal use. Yes.
So like the scenario where you have Plan 9 on a blue gene, you might use that as the big computing server.
Oh yeah. So what we do is BlueGene's a very special architecture. It's got compute nodes and I/O nodes, and so they run the I/O nodes as authentication and file servers, and then the compute nodes are all CPU servers. And so what it does is you run it on 1,000 nodes, and then you get a lot of power. And because of the way it's made, the way it's network transparent, it's very easy to launch a program on 1,000 nodes. All right, demonstration. First demonstration is, since this is a network booting terminal, I'm just going to turn it off and reboot it. It doesn't hurt the disk at all because the disk is upstairs. This will also give you an idea of how things are working on this. A little slow to boot.
Are you plugged in over Ethernet?
I am plugged in
Yeah.
via Ethernet.
And you can you boot over Wi-Fi, or is that just horrendous?
You can. There's a depending on how good the wireless is, it'll take 2 or 3 times as long on wireless because it's just a little slow, or at least with my card. There may be better cards. Okay. So now it's asking me where I want to get the root file system from. I could boot it from the hard disk on here, but I don't want to, so I'm going to say boot from TCP. Ask me for the file system. Who am I? Alright. And so boot straight into the graphical system, which is pretty common these days, I guess. Alright, and here I sit. It's loading up faces, which are all those things flickering past, which show who I have email from. Those are from last couple of years. So since I've just started up, maybe I'll see what I got for email. I've been getting a lot of spam lately, but let's see. So I just opened the editor. This is called Acme, and you see there's the up here. Do you see the mouse? Okay.
Yeah.
So here it's showing me all the files in my home directory. And I've just opened the mail program. Now how I did that was I moved my mouse up here, typed in mail, and middle clicked it. That said execute the program called mail. It shows up down here. And okay, let's see, this one's new. So I opened it by clicking on faces, which sent a message through the plumber system to mail, which said, okay, open that mail. Oh, yep, spam. There's a spam filter running on this, and so it caught that was spam. All right, and got some chatter on the mailing list. Okay, and now say, all right, I don't really care to save this or anything, so I'm going to middle click on delete message, and it's deleted it. All right, save that, and close this. Now if I wanted to, I don't know. Yeah, let's look at my old Datacom notes. So I right-click on this file, which opens it. You select, type stuff. Hi. And then, now some of the things, optimizations for the mouse use is, if we want to copy or cut and copy, I just select it, holding down the left mouse button, and then while still holding down the left mouse button, I hit middle click, and that cuts it. This is called mouse cording. It's done throughout the system. And then if I want to paste it back, I just left click again and hit the right button, and it pastes it back in. All right, enough of this silliness. Right here I've just opened a new shell window. Just did that by right clicking, saying new, open a new one. Yeah. And it feels a lot like Unix, PWD. Okay, that's just me. Let's see. I'm going to show you the snake program I wrote. So cd snake. So the B talks to the plumber again and says, open this in an editor. All right, here we go. A lot of C. You guys all know what C looks like. All right. Now to compile this, you say 8c snake.c. That compiles it. Now in here, snake.8 is the object code that came from the compiler. Now I gotta link that 8L snake.8. And now 8.out is the freshly compiled binary. So run 8.out. Hey, no snake. And so this took me all of an hour to write. That included figuring out how that included figuring out how to use the graphics system. So like I said, it's not hard to figure out. I took the clock program and hacked it to do this. Basically, graphics is not complex. So now let's show you some more features of this thing. If I was to, I don't know, foobar. If I was to screw this up, I introduce an error into my source code. Uh-oh. Okay, so it says on line 35, there's a syntax error. I click on this, snake.c:35, and I say plumb. That talks to the editor and says, show me line 35. Well, here's line 35. Since I didn't put a semicolon here, that's why I was telling you there's a problem there. So I see what the problem is, I fix it, do it again. You don't hit up arrow or anything to recall previous programs. You just select it and hit send, or go up here, edit snake.c. You could do that kind of thing if I actually had boot up our program. Yo.
What did Snarf do?
Snarf. Snarf is the equivalent of copy.
Oh, okay.
They got a little silly. I think they came up with all these names before anybody decided that copy is what we're going to call it. It was also the 80s. Gotta give it-
Better fun.
Yeah. Now, a few more things. Let's show you 9FS sources. We have one server located at Bell Labs for storing all the changes to the distribution, and then you can get your own personal source folder on there. So 9FS sources say, okay, import the file system from the sources system, and then it's mounted under /n/sources. Now ILC, here's all my stuff. Contrib, this is where people get to put their own things. I can get one. And so you got stuff. This is all sitting in Bell Labs. If I wanted to, I'd just could drop new files in there, could copy them off. And to all my programs, it looks like it's a local file system. I think there's something similar to this in Unix now with Fuse. Anybody use Fuse?
Yeah,
Okay.
I'm actually
You already know about Plan 9 though.
true.
But you don't count. And one final thing which I've always found rather useful, you use the CPU program to connect to a different server. I'm going to connect to mine, the server I have running at home. All right. It asks me for my password. And now I'm logged in there, and I can start the Windows system over the network. No tricks needed because it doesn't really know where the window is or where you're coming from. It doesn't really care. As long as it has a window, you can run any graphics program. So now I'm on a different file system somewhere. Yeah, now I'm at home. Okay. Let's see. I will bring up now. That's it for the demonstration, unless you guys have something more you wanted to see. Yeah, Nick?
So is 2009 the year that Plan 9 takes over the desktop?
This is indeed the year of Plan 9 on the desktop. Yes.
That's all right.
Just get
Linux and those
get
tend
the
to be
last couple
disappointed.
slides of this. Oh, I'm sorry. Yes.
Oh, it's okay. Just yeah, I think before you had said you implemented a lot of Unix-like things with simple shell scripts.
Mm-hmm.
Did you have some examples of that maybe that would be of interest?
Let me see if I can remember one.
And while you're doing that, what shell is this? You said RC mostly?
Yeah, it's called RC. It was originally on version 10 of Research Unix, but okay, so you can see here that a lot of these are shells, or a lot of these are shell files. A lot of these are compiled executables. Let me run this again, and I'll find one that's actually a Unix file or a Unix program rather than.
Is there grep?
Oh, there is grep. Yeah.
There it is.
Oh, there it is.
All the ones that start with underline are old versions that they keep around for potential compatibility problems. There we go. Any other questions while I'm looking for this?
Yeah, I had one.
Yeah, please.
I tried screwing around with the two things. First of all, the way it does devices with the CTL file, not just devices, is kind of interesting, but there doesn't seem to be a lot of documentation on what is actually valid to echo into a CTL file.
Mm-hmm.
Is there some way to get that from the file system layer itself, or did they basically just tell you to go spelunking in the source code?
Splunk in the source code and read the manual pages. Really, between the man pages and the source code, that should have most of what you need. I did some work with a device thing myself. It really should tell, like, the source should have a very clearly designated place where you can see where all the possible commands to be written are. And you know, I can't see off the top of my head right now, guys. A good example of something that's a shell script now. They gave one in the paper, but I don't remember what it is. Sorry. Yeah, I've got nothing. No, yeah.
Who?
Okay.
Actually,
How do you find Plan 9 as a developing environment? Meaning, if you know you're going to be developing C programs or Perl or anything like that, how do you like it?
Really, I loved it. When I find myself going back to Unix and like writing C and Emacs with GCC and stuff,
Yeah.
it's not as nice or convenient. I spent 6 months writing C code for Sandia National Labs on Plan 9 every day, and I got really comfortable with it, and I feel like I was a lot more efficient with it. And so now going back to Emacs, it feels kind of like a step backwards.
Can you explain how to use the net file system a little bit? I tried screwing around with like making a connection and maybe like getting some package from Google or something.
Okay, so I haven't played around with net too much, but under /net we have all these different things. We could go into TCP, and so it looks like I've got 5 network connections open with 5 TCP connections open. Now I don't know for sure, but it looks like, as I recall, if you read clone, apparently, so it gave us back 4, which means that network connection 4 is ours. And let's see, now we have control, status. And so if you write stuff to control, you can write commands into control, and I don't know what they are at the moment. And you can use that to open your connection to a remote system. And then you just, I believe you just write into the data file, and that gets sent across the line. If you want to program it, there's examples on network programming. I don't really feel like I have time to go into those, but I wish I knew more about net to tell you more about that.
How well does Plan 9 work on a multi-boot system or via virtual machine?
Okay, so did you see when I was rebooting? The best thing is if you've got Grub or a NetBSD bootloader, it works pretty well with those. I've never had any problem with it. Its own bootloader is not complex enough, or it's not designed to do that.
Okay.
So you want to chain load from Grub or something like that. Yes?
could you just like take a look at the Whois utility? Because I noticed that one was a.
Oh, excellent. Thank you for catching that. Whois? Okay. Yep, and that would be it. So that's all the Whois program is. These couple lines. And that's really a artifact of how we do authentication. It's all in one place, it's represented in files, and those readable files, the files which are readable, not the secret files which hold passwords and such, those ones will allow you to just figure out who somebody is. Any more? Yeah?
So I saw that you could change which the CPU server that you use. So let's say that, is it possible to do something like you're on your computer, you're doing something normal, and you're using some like kind of cheap CPU server, and then you decide that you need to do some research, you need to load up a really, really powerful CPU so that you could run, you know, something maybe on a supercomputer. Is it possible just to take your current file system and everything that you have and just switch the CPU and nothing else?
Yes. Well, so here's something you can do. You can do CPU-H P9-C, I believe it's -C, LC user. So that should run the command lc/user, which it did on my remote computer. And you see that there's, if I run it locally, we have different set of users. Whereas on my remote computer, we've got, you know, this is the equivalent of the host owner. Glenda is the default. John is me. Arminich is my boss. And then this the latest /user is my computer here at RIT. What else? Should I continue? Okay. So I just got a few more on. Oh, yeah.
How secure is Plan 9 compared to like Linux?
Oh, so the ALS server, I don't yet fully understand how the security works. But Russ Cox, who was from at MIT, he did a lot of the new security system, and I've skimmed through his paper. It looks pretty good. What it seems to do is passwords never actually get transmitted over the network. There's a lot of hashing involved, and so you transmit, as I recall, you transmit hashes in plain text, and then can compare them at each end. I wish I could tell you more, but I have not had any opportunity to mess around with the security thing. But if, for example, I was to telnet, which is not really recommended, but you can do it, telnet into this server from anywhere, it would, instead of asking for my password, it would show me a challenge. And then I use a different program running locally to, you type in your password and the challenge, it gives you back a response. You type that response in, and then the server says, okay, this response is acceptable given the challenge and the password that I have on file. So you never transmit the password, and then you can't guess what the password is by sniffing the network and finding out what the response was. That gives an example of how it works.
I just
So,
Okay, what's the challenge? Like, what's that?
let me see if I can show you. Telnet, CS Plan 9. Okay, so user John. It gives me a challenge right there. Okay, so over here I run the netkey program, give it my password, type in the challenge, and that gives me this response back. All right, snarf that, paste it, hit enter, and there I'm in. And you're gonna do all your telnet things. And then when you're done, you control D and I'm back out again. So that's what the challenge response looks like. And I think essentially the same thing happens when two Plan 9 boxes are communicating with each other, except they can do it automatically. You don't have to type in the challenge and responses. Oh, yeah.
one thing I would just mention is that Plan 9 doesn't actually have a concept of a root user either. It's
Right.
pretty weird because the bindings for the file system are per process. So it basically just boils off by the security concerns because it can only act within its own view of the file system. So as long as the file system has a authentication layer, you're all set.
More questions? Jeff?
I noticed you run your PowerPoint or whatever program that is on. Are there any other common applications for Plan 9 that people would be other than development tools, of course, that people would use on a common basis?
Well, so we have, it feels like we have just about everything except Firefox, really. And that's basically what every new user on the mailing list will ask about. They're like, oh, so what's a web browser? Where's Firefox? Plan 9 is it's decidedly anti-web. We do have a browser called Abaco. It's not particularly complex, but it'll get the job done if you're not trying to do too much. It does Gmail, but you know, HTML mode. We're not really web people. It does have an HTTP server running that right now. But beyond that, you know, you've got mail. You can import mail from various other, like you can import it from Gmail and it'll show up on here on the Faces program. So it'll look just like local mail. What else? There's IRC, AIM, what else? Document typesetting programs like Trough. I use Trough a lot.
So are these ports or are they just natively written?
Some of them are ports, some of them are natively written. Like the Epic IRC program has been ported, but Trough was written natively.
I think I just saw somebody ported Vim, didn't they?
Vim has been ported, and like over the last co-op, I was working on the SSH port. Somebody else has done it faster and better now. But so yeah, there's SSH, there's Vim. Although you shouldn't use Vim because Acme works better. But there's a lot of ports and a lot of stuff under /contrib. Really, you just kind of got to poke around and keep discovering new stuff. I've been finding new stuff even now.
What are those little CR symbols after one of the files?
So what that is it's actually displaying carriage return, which is a displayable thing. There's an option to Telnet to turn that off, but I didn't bother to put that in. Yeah.
So, just to put this in a different contrast, if you were, let's say, a cushy Mac user, and you were used to your, give me my iChat, give me my Safari, and my Time Machine right now, and I want it to be easy, Plan 9 probably doesn't do that right away. Do you see any vision of Plan 9 going that route?
So I'm glad you asked that, because I kind of forgot to mention this at the beginning. Plan 9 is and really has always been a very research operating system. And if you were to suggest make it cushy Mac OS on the mailing list, which is where all the developers are, you'd probably get flamed all the way off the internet. Somebody would come and cut your wire at that time. But there's nothing to stop you from making it like that. It's not particularly hard to write programs, and you can rewrite. Heck, if I wanted to, I could run Acme instead of this window manager. I just changed one line in my profile, and it would start up Acme instead of the window manager. So you can easily replace the window manager. But the thing is, as they say, if you want Linux, you know where to find it. And so there hasn't been much work in that direction. I'm gonna tentatively bring back up the last few slides of this thing. So as I mentioned a few times, as for our community, there's the 9fans mailing list. There's some flamage if you act like a newbie, but a lot of really smart people, like Dennis Ritchie's posting on there. A lot of people who worked at Bell Labs and are now at Google. In fact, I'm pretty sure they sent all of us job offers from Google one day, just because of what goes on that list. There's a workshop every year. This year it was in Greece. The year before it was in New Jersey. I actually got to go to that one. Very good. Well, it was in Jersey, but it was also at Bell Labs. So I got to see the room where Unix was born, which was impressive. There's also co-ops and jobs available for Plan 9. You can work at Bell Labs as an intern. IBM is doing a lot of work with Plan 9 on the Blue Jeans. I've gone down and worked with them in Austin. Real smart people there, and a lot of fun to work. And then where I was working, Sandia National Labs, they've got a program going on there too. Really, all three of those places are working together on the same project. Going to get Plan 9. It's free now. It uses a Lucent public license because we're allergic to GNU. There's the official site. You can Google Plan 9 or just 9fans.net redirects to the official site. CD image works on pretty much every I shouldn't say pretty much every PC, a lot of PCs, the hardware support can be hit or miss. It works on QEMU. VMware and Parallels need a little bit of workaround, but it works all right. And finally, we've got a server here at RIT if anybody is interested in trying it but doesn't want to install their own box. It sits right upstairs on the 3rd floor. Anybody in GCCIS or KGCOE can get an account. There's a website, csplan9.rit.edu. Personally, I use it for reading mail. Like I showed you, I've got my 9fans mailing list forwarded to that. I write papers on it. I wrote, papers at my job in California, and I've written stuff for here at school. Do some programming on there. I'm still a part-time employee of Sandia, so I use Plan 9 on CS Plan 9 to do my programming. And it's a real convenient place to, keep the occasional file, do some shell access. And that's it. Any further questions?
Coming back to one thing which I wanted to hit on, which you mentioned just recently, is why is Plan 9 so allergic to GNU?
I'm not really sure. In part, it's because the utilities have really diverged from how Unix is and how we think Unix should be. Partly, nobody seems to like Richard Stallman very much.
Is it his hair?
Yeah, and the smell and all that. And also, it's there may have been licensing problems back when they first started writing it. It was non-free. I don't know if they would have been allowed to use GNU. I'm not really sure. I think partly they also wanted to just make their own, entirely their own operating system, and not have any legacy in there. Yes, Nick?
How did you get started with this?
I'm not sure. I think it was my freshman year. I'm Googling around to say, oh, this sounds interesting. Let's try this.
2 things. One, I don't know if you've heard of it, but somebody started a project called Glendix.
Glendix, I have heard of Glendix, yeah.
I haven't tried to get it to run or anything like that, but anyway, if anybody's interested, it's basically some patches to the Linux kernel to turn the Linux kernel into the Plan 9 kernel.
Yeah.
Because hardware support is not
Right.
there.
Hardware support on Plan 9, not great. Hardware support on Linux, really good.
The other thing is I'm working on some user space file systems to kind of make Linux grab a couple of the ideas from Plan 9 if anybody's interested in that kind of thing.
Yeah.
Right now I'm working on something that gives you something kind of like /draw for X11.
Have you talked to Eric VH about this? Eric Van Hensbergen at IBM?
No.
Okay, he does a lot of V9FS stuff, Fuse. We should talk to him. Stump.
Where's the name Plan 9
Retreating.
come from?
Oh, I didn't mention that. There's a very old, very bad movie called Plan 9 from Outer Space. And I think it was Ed Wood who directed it. And that's where the name comes from. They call it Plan 9 from Bell Labs. That's also where the name of the bunny that I showed you, Glenda, comes from. It's from another of his movies called G for Glenda or something? About a transvestite in New York or something. I'm pretty sure it was also a rather bad movie, but that's why Plan 9 will never make it on the desktop, because we have a goofy name. Is that everyone? All right, great.
Thanks again.
Thanks for coming.
All right, so 2 things. First, if you're an SSE member, we're adding Plan 9 from Outer Space to the Pick an Event. Second of all, there will be another Tech Talk next week. I'm giving it. If you're a Ruby on Rails developer, shame on you. If you're a PHP developer, I'm going to show you a cool framework that you can use that's pretty similar to Rails. Actually, it's almost blatantly a port of Rails for PHP. So same time next week. And if you have any other questions for John, it is Cake PHP. Oh, that reminds me. Because it's Cake PHP, there will be cake. Literally, I will be baking a cake. So show up for that.